Okay, this is a continuation of writing formulas and names for ionic compounds. My video just stopped. I apologize. Okay, so we were on rule 3, which says that I'm going to indicate the number of ions using subscripts. And subscripts come below the letter. Okay, so it's like the opposite of an exponent or a superscript. So what I do now is I look at my formula, okay, or my set of ions, which was I have an Mg plus 2 and an O minus 1, and I'm thinking about how many of each I have. So I have 1 Mg, right? Now I know it's charges plus 2, but I have 1 Mg and I have 1 O, which means that my formula for magnesium oxide is MgO. Now technically it's Mg1O1, but just like in math class, I don't need to write those ones because they're understood. So my formula is MgO. And then in my second example, I have Fe plus 2 and Cl minus 1 and Cl minus 1. So when I go to do my formula, how many Fe's do I have? Well, I only have 1, but I have 2 chlorines, so I'm going to write it like this, Cl with a little 2, like that, okay? And so that formula is read as FeCl2, and that's my formula for iron 2 chloride, okay? So there's a whole set of practice. There's like 12 of them. I'll do the first couple, and then what I would suggest is that you pause the video and you try them, and then you can unpause the video and check your answers. So let me write the first. I'll put the first 6 up here if I can fit them. Calcium oxide. Let's see. So we're going to follow the same set of rules when I do these that I did just in my examples. And we're going to write formulas for these ionic compounds. Copper 2 iodide. Okay. So if you think you can do this without me, I would pause this video and try them. And then if you want to see a couple examples, of course, you could pause this at any time. So lithium fluoride, that's lithium plus 1 and fluorine minus 1. Okay, so I look at my charges. I got a plus 1 and a minus 1. They add to 0, so I'm good. So my formula is just I have 1 Li and I have 1 F. And that's it. I'm done. Okay, some of these are very simple. My second example is potassium chloride. So potassium is K, and K is also plus 1. Chloride is chlorine. Chlorine is Cl minus 1. For the second time, I have a plus 1 and a minus 1. Adds to 0, so my formula is just KCl. My third one, calcium oxide. Calcium's charge is plus 2. Oxide, remember, is oxygen, and oxygen's charge is minus 2. This time I have a plus 2 and a minus 2, which again add to 0. So I have 1 calcium and 1 oxygen, so CaO. Okay, so those first 3 were pretty simple. They're all what we would refer to as 1-to-1 ratios. There's one of this and one of this, one of this and one of this. Okay, so if we keep going, magnesium chloride, so Mg plus 2, and chloride is Cl minus 1. Now here's your first one, where plus 2 and minus 1 do not add to 0. So the only way you can get it to add to 0 is to add a second chlorine. Now I have plus 2, minus 1, and minus 1, which is in fact 0. So my formula would be I have 1 Mg, but I have 2 chlorine. So MgCl2 would be my formula for that one. My next one is iron 3 chloride. Okay, remember this is indicating the charge for a transition metal. So iron is Fe. This is Roman numeral 3, and it's always a positive 3 because it's a metal. And then chloride is chlorine Cl minus 1. Plus 3 and minus 1, they do not add to 0, so I need 2 more chlorines for a total of 3. See, plus 3, minus 1, minus 1, minus 1, that is -3, so they cancel out. And my formula is Fe, 1, 2, 3 chlorines. So my formula is read as FeCl3. And then copper to iodide, so it's another transition metal. So copper, in this case I'm being told, is +2. Iodide is iodine, whose formula is I -1. I need a second I. +2, -1, -2. Add to 0, good to go. 1 copper and 2 iodine, so CuI2. Okay, those are the first 6 examples. And now you are writing ionic formulas. Or you have learned to write ionic formulas. Oops, oh, sorry. Yikes. Okay, and then let's do these last examples real fast, and we'll check and see how we are. Let's see, aluminum chloride. Eventually you're going to be able to do this in your head, but that might not be the case right now, and that's okay. And so for now, I recommend that you write down your ions and you equal them out just like we've been doing. Later, you know, it'll be easier for you to do it in your head. Okay, so here's my second 6 examples, and okay, let's just get to it. So this is actually the hardest one on here. So if I look at it, I have iron 3, which means it's iron +3, and oxide is oxygen -2. And looking at it, you might say, this one's not quite so simple as the other ones were. Okay, so you think 3 and 2, how am I going to get that to equal out? But so there's a kicker. And anytime I have a situation where I have 3 and 2, the magic number that I need to think about is the number 6. I believe that 6 is referred to as the least common multiple of 3 and 2. I think that's the right terminology. And so what I have to do is get the positive charges up to 6 and the negative charges up to 6. And so if you watch, it'll work out. So if I add another iron, I have +3 and +3, and that's +6. And then the issue would be, could I get -6 over here? And the answer is I can, but I have to add 2 more O's, because check it out, -2, -2, and -2 is -6. So I have -6, +6, there it is, and my formula is Fe2, right, O3. So that one's a little bit different. Fe2O3 is my formula. Calcium sulfide, calcium's charge is +2. Sulfide's charge, that's sulfur, is -2. So formula is CaS. Right, +2 and -2, add to 0. Barium chloride, barium is +2. Chlorine is -1. Okay, they don't add to 0, but it's an easy fix. I need a second chlorine. And then I have barium, 1 barium, and 2 chlorines, BaCl2. Aluminum chloride, aluminum's charge is +3. Chlorine, of course, is -1. +3 and -1, I need 2 more chlorines. Now I have +3 and -1, 2, 3. So AlCl3. Sodium nitride, sodium is Na+1. Nitride is nitrogen. Okay, and again, we're going to talk about that in a minute, about why that name has been changed. So sodium nitride, so N, and N is -3. So I have a -3 and a +1. In this case, I need more of my +1s, right? +1, +1, +1 is +3, cancels with my -3. So Na3N. And my last one, potassium nitride. K is +1. Nitrite again is nitrogen minus 3. It's the same deal as this. I need 2 more potassiums. And my formula is K3N. Okay, and that is how you write formulas for ionic compounds. Okay, and actually I've now decided that we're going to do the back of this in a different video. Okay, this section here, I'll go ahead and stop this video and do it in a second video so that then they're like, you know, just classified based on whether you're naming or writing a formula.